Hello and welcome again to Steve's Long-Stay Workshop, where sets come to a loop chat for various reasons. I was at Goulburn this weekend, Goulburn being a place where people go to sort out, well, each other's crap basically. And I found this. This is a radio, hooray. But it's not any radio this, it's something which people are going to be interested in. It's a Ferguson. But it's very different. That's the circuit, yeah. But the circuit is not like the radio, because this radio is a 5-valve radio, and the circuit, the nearest I could find for it, is a 4-valve radio. But it's close enough, okay. Now, somebody had done work on this in the past. Capacitors were faulty on it, and I went, but it's basically been a bit of a mess, and it is going to need some, well, quite a lot of restoration. Turn it round, by the way, like that. You see, it's a bit like the VHF 81 in the way it's done in one respect, but the difference with this set, and it's an interesting difference, is that this set is well, different in that the chassis is not connected to deck, and nor should it be. The circuit is very similar to what you get on the 4-valve battery radios, in that the voltages are such that it generates a minus voltage for bias, particularly the output valve. And so it's done in that sort of way, and so with that in mind, having looked at the circuit before I came on, I'm not going to put this in straight away because there's no point. There's various things to do on it. First of all, anything like this, that cable has to be changed at some point. I'm not going to do that straight away, but I'm going to look at this set in general and see how best to make it safe as well as working radio. Most of it is like any other valve radio of its type, but unfortunately this here is the VHF, is the bit that generates a negative voltage. If you look at the output valve, it's a Euro 41, it goes to deck without a resistor, yeah, and so this voltage is lower, and it's held there by these two resistors and this capacitor here, you see, and also it generates a voltage here for the AGC and whatnot. So it's done a different way. I can't put it auto deck after. I will not do it. So we'll look at it as it is and take it from there. So let's get started. When the set that's been worked on, it is a bit different, like this. Pair, P-A-I-R, is very, very important. Yeah, power supply, audio, IF and RF. That's how it works. Yeah, it's got to be done that way. Okay, got to work your way through. So that's what we're going to do, and I'll start actually by we're looking at the valve chain here, the feeder chain, which goes to deck, goes below deck here, you see. So this goes to mains neutral via the lights, yeah, and that capacitor there, but also from there it goes to chassis neutral via these uses here, like I said. So first of all, we get to look at the AC valve side of it. As anything with a set like this, yeah, the most important thing to remember is that it is an AC/DC set, and so I am going to change the cable like I said. But the first thing I'm going to do here with this is get the valve heaters working. I know other people been in here before because all the capacitors underneath have been changed. Well, most of the ones, which generally speaking, sets of this era, Phillips used them, but Ferguson didn't. So somebody had done a lot of work on this, and it's not worked out. Probably because he didn't realise about the bit like this here. So I'll get it set up, and we'll take it from there. Oh, mistake number one, it is a 4-valve radio, so this circuit is right, but everything else I've said about it is correct. So first thing we do is look at the various parts of it and see what goes where. First of all, that one strand there goes to deck, which we'll see if we put the meter on. There you go. That shouldn't go down to deck. It should be 200 ohms in the way, which is probably going to be somewhere on here because that little coil there is on the circuit here as L9 and L10. You see? It's right there. So let's see where that goes to. So what I do with it then, I'll put it on the chassis here, you see, like that, and look and see any of these, like that one for example, should be where that wire should go. So we put that right, and another thing I'll do at this point, by the way, is take the voltages, the 80 voltage off the rectifier. I'll do this just so that we know that all that happens when I plug it in a moment is these valves should light up. Also, but I noticed with this one, it's set to 220 volts. There are various reasons why people do that to radios, and one of them is that if a radio is dying in its fuse because of losing emission, they would actually move it down a peg on there. They get more life out of the valves. So that for these valves doesn't look all that good, but I'll put that right as well. So put the meter away for a minute, like that, and get a screwdriver, everyone that works, and take that off there and put it on the correct one at some point. Also, I think I'll probably take away those as well, because that's asbestos, so I really don't particularly want to have those on there. I might actually replace that with a dropper. We'll see what happens there. But for now, I'll leave that for now. It's going to come out anyway. And put this lead, which was on here, onto here. So first thing we do is take that lead off there, like that, and put it where it should be, which is on here. Because the reach, that is. Not a new length away will be required. I think a new length of wire will be required. So I'll get one for somewhere, and we'll carry on from there. So what I've done here now is I've taken off the DC for the rectifier, which is, I think, this wire here. This wire goes well, the cams, it carrying HT. This carries HT to frequency change the valve, and this wire I don't know. Simple, innit? But at this point now, what we have on the circuit is we have the switch, L9, the valves, the bulbs, L10 in here. And so let's see what happens when we and I'll please get ready for a loud bang. Here we go. Bangs are what comes on okay, but it goes down okay. Now I don't see why it should go down, but it does as the valves warm up. So obviously looking at let's look at it from this angle now. It looks very much as though something is not quite right, as it were. Now, we don't go onto the chassis here at all. All it is that, and that. Okay, with that in the way, but at the moment, and that as well. So, if we look at across these bulbs here, we should have a value, a voltage of sorts. Well, we do, but obviously it's lower than it should be. The valves, by the way, again, a lot dimmer than they should be. I think anyway. But there's no HT, so they're not doing anything apart from light up the valves, so they might be alright, I don't know. But the rectifier should be rectifying even though it's not going anywhere. But the smoothers won't be in circuit. So what I'll do is I'll have a look round here and see what voltages we have coming out of here. Nothing. Nothing. Let's try AC. 133 volts AC there. 95 volts AC there. That one is 147 volts AC. Yes, fine. So 240 volts AC there. That's obviously mains voltage there. Okay, so that goes to there. So what is this one here? Probably mains, isn't it? Okay. And so there now there should be something on the AC line. 100 volts AC. Well, again, there's no smoothers in place, so it will be lower than it should be. But it is doing something. That rectifier might be tired. I don't know yet. But we do have the valves just in case. So next thing we do is, as the song goes, let the dog see the rabbit. So what I'm going to do, get the speaker out of the way somehow, these screws here, and hopefully the dog will then be able to see the rabbit. And kill it, of course, you know, but there you go. What's that outside? Okay. So these come off here, and the speaker should, yeah, I'll find out later. These come off here, and the speaker should come off down the front. I hope. Okay, that one, okay. And this one here. That comes off as well, so that comes off like that. Thank you very much. And that speaker should come out the front way, I think. But it should. It should do. Whether it does or not, I don't know, but it should. That's got one, by the way. That's got one. So obviously, that's working okay. So anyway. So, hang on, another screw. Bigger screwdriver, hang on. Bigger screwdriver, like that. And the speaker should come off like that. Thank you very much. Off it comes. Come on, out, out. Thank you very much. And this beaker should now disappear at the front, which it does. Okay, right, now we're getting somewhere. Okay, so therefore this wire goes to the 8-put valve, that isn't it? No, it's not, it's that one. Okay, fine, that one goes there. The 8-put valve, I think, is this one here, and so therefore it should be possible to get the draw circuit of what this should be from that, which should be interesting in itself. So I want to know why those bulbs are so low. I want to know that. It's important, because if them are low, then the valve heaters might be low. If the valve heaters are low as well, then yeah. So another thing I'll do is I'll take our 21 den up to where it should be as well, and yeah, I'll put C29 back in, take out R11 and R14, and we'll see where it's like then. Oh, and I'll put C32 back in as well if I could find it where it goes. Right, okay. So, to deck, what do we have? I'll pull the meter up front where I can see it, and where I can see it. There we are. That goes onto there. Well, but by the code that actually goes onto there, and 220k, 220 ohms or thereabouts. Okay, fine. Now, it shouldn't be any other way to deck apart from that. So yeah, those obviously the heater pins there, and so that's the one. That's obviously the 8-put there, and that's the mains input. Okay, so we're getting somewhere anyway. So mains input, mains output, and the mains output goes to C32. Goes to C22, and of course this lot here, which should go to deck, but as of yet it doesn't do. Not correctly anyway. No, it shouldn't go to deck, should it? Hang on. Then with everything switched off, there are no dodgy current drains apart from possibly DUF batteries, DUF capacitors. So that could be it, couldn't it? So yeah. So if I put this back on the output here, like that, yeah. That goes on like that. That goes on there like that. And let's see what we have here now, shall we? Right. Nothing. Okay. Okay. So obviously that goes to negative with that capacitor, and the positive with that capacitor goes to well, the V4 and R19. So I'll put that capacitor in as well, and we'll see what else needs to be done. Now, with these sets with a transformer, you've got to put all the valves in to get the heat exchange to work. So the idea of taking valves out and putting them in indifferently, that is not there with these sets. It isn't there with these sets. So it's a little bit interesting that way. Now I don't not mock the transformer sets, because transformers cost money. Resistors, well, they can be taken out and placed with other resistors or a capacitive dropper or whatever. R20, by the way, is 140 ohms to the grid. So let's see where that is, shall we? It's there. Okay. Now, okay. So I need to place that and find out the voltage there. Taking out. No, we can't, can we? Oh, rotten. You rottens. With something like this, the first thing you do is get the calculator out and do some maths and check a few things. First of all, off the circuit here, it tells us that R2120 is set at 1.2 kiloohms for 240 volts, or 239 it is here, so I'll move that up, okay. Now the valves, by the way, together it's 31 volts for the rectifier valve, 45 volts for the output pentode, and another 31 volts for the other two valves. They are in series, of course, and so therefore I should be around about 107 volts or so. It's 110. That's near enough, okay. And therefore the bulbs aren't getting the current they need, of course, or the voltage they need, so they will dim. I'm not bothered with that for now. What I am bothered about, however, now with that working okay, is getting the AHT up. Now, as I said, this first capacitor from the rectifier valve goes to main via the bulbs in neutral, of course. Again, if you look at the circuit here, you see, it goes from there to there. That's the on the grid bias circuit here, and from there goes to the bulbs to neutral there. Now that there's not enough voltage on those, so they're not going to light up. What I'll do there is I'll look at making sure the voltage is okay and putting smaller bulbs in. That's for the future. Okay. So now, of course, therefore, we now should have, if I power this thing up, hope it doesn't go bang. What do you mean you hope it does, cheek? Anyway, so now, okay, yeah. When we go to deck, between the deck and the rectifier valve, there should be more voltage because it's smoothed. And so 600 volts there on the meter. I'll just put it up so you can see, like that. Can you see that? There you can, okay. And we're going here. That's 216 volts. That's a bit right. So we know therefore that the rectifier appears to be something approaching okay. And of course, now of course, we've got to sort out the other side of it. Now, again, looking at the circuit here, you see, these two go to deck and to these two resistors here. So I'll build that lot up, yeah, and that will of course also supply the second voltage, so it's screen give voltage for this pentode here, and so we shall get something here. What we do in that situation is go onto R15 there on the valve base there, and we shall get home. If we do, that is doing something right anyway. That's the next step. The power supply is in and working, I hope. We'll know in a minute from now. Okay, so now with it on like that, we put that on there with it switched on and working, and it should come up. It should come up. It's coming there. Hang on, I'll put it where you can see it. Hang on. Can you see that? Can you? Yeah, you can. Okay, fine. Okay, so now it goes. It's okay here. Yeah. There was. Get a hold of the meter. Thank you very much. Try that again. That's okay. 200 volts. Okay. And the power supply, it comes out at 174 volts, and there at 90 volts. Okay, so all that lot seems to be okay. Now, therefore, next place we look for something interesting is that's looking is the UL41, and the UL41 should give a buzz. It does there, okay, and it's also give a buzz. Ah, that's why that does that. Okay, fine. Doesn't give it there. Okay, fine. Well, that's something. We know something now, don't we? Right, okay, so therefore we should get a buzz here, and we should get a buzz greatly diminished there. Okay, and from there it goes to measure the voltage, the put that back on again. Okay, so now of course the grid volt, the minus grid voltage you know, 10 volts of there, but again, that's okay. Okay, so let's do a look here, and this seems to be out, and here as well. Okay, right. So that's the next place we'll look. So we take it off, and we know that from the circuit, from the other end of that resistor there, which is R15, from the circuit. There's the circuit, R15, which is that one there, feeding the grid. It goes to R14, which goes to the grid circuit, and also goes to C27, which goes to R7. So we look for those, and we take it, well, from there. That goes to there. Okay, so that is the so that therefore goes to the grid circuit down here. Okay, so R14, which is that one there, the circuit again there, that is 470k. It looks like that, but I'll check and make sure. So from there to there, it should be about 470k. I'll check. Might not be in circuit, but it was checking. That's okay. That's okay. So that's okay. Fine. Now also from there should be a capacitor, which there doesn't appear to be. I don't think. So something has been wired up wrong down here, because the capacitor goes to R7 on the circuit there. There's two there which go to deck as well, so I shall now get on the phone and well, on the internet via the phone, and see about R7. It goes to the coils to the deck here. So obviously that must be R7 there. It goes through here like that, to deck, and there's something very, very funny here. I don't mean funny ha either, perhaps it's this one here. So that one, that's the UCH, that's the UBF, and that's the UL. So it's gone 2, 3. So it's probably going to be this one here, isn't it? So I'll have a little look at that coil and see if it's got any voltages on it. It should have, on one side of it, when the power comes up, it should have a voltage on one half of this. It should have. It comes up, okay, so nothing, okay, and 79 volts there, okay, nothing there, that one under there, 69 volts, okay, so this must be, so that resistor may be high. I don't know what voltage is on that valve. I'll check, but it's not on this circuit. But that shouldn't shut it up completely. So that goes to deck, okay, fine, okay, that must be C31, sorry, 321. Okay, so which one is C27? R15's here, and so there should be a capacitor here as well, but I think it might be this one here, mightn't it, which has not been changed. So I'll start from there. Of course, there should be something on V2 here, which again there is. Okay, so getting as far as something is getting as far as V2. Okay, right. Okay. So why isn't it making any noise? It should be. I'll have a look and find out. Again, that capacitor does not appear to have been changed. I think it should be. I really do think it should be. So I'll do that, then I'll come back to you. Yes, that was a Hunt capacitor that was left in there. You see that? When all others had been changed, the one that really should have been changed was not. Clever that, isn't it? Anyway, that's what's happened there. So now, let's see what happens when we give it some power now and see what it has to say to us, if anything. Boys on full. So we'll watch that come up. coming up. Okay, so the balls, by the way. Okay, so so there we go. That's all. Okay, that's okay there. Doesn't do a lot there still. So okay, so that must be said there. Right, now that 10k goes to the power supply. So we'll check on the other side of that. 79 volts. So okay, that goes to there. 79 volts there. That should be enough, but I'll check that anyway just to be sure. And of course, this capacitor here. These don't fail normally, but they've been known to. And these days, the kit is so old that nothing to be taken for granted. So yeah, volume control, by the way, we have something there. Is it there? No, okay, but it's there, okay. So it's there, okay, so that must be the wiper, which goes to deck. No, it doesn't out there, does it? I think we'll work. We'll have that resistor, have that capacitor out and see if it now does anything. No, it doesn't. Okay, fair enough. And so there we go to that's there. Okay. Right, okay. Time for my head scratching. See what else has been done with this that maybe shouldn't have been. Something as simple as a capacitor or a resistor or a wire in the wrong place can cause this, and you can really end up going round the houses. You really can. Well, this radio's taken a turn for the worse. Basically, this radio has had the output valve killed off by that one capacitor which should have been changed but wasn't, and also the IFs are way off. I mean way off. And the problem is these. That is the inside of an IF cam, and they're both faulty, both of them. And so that's on apart. What I've done, I've taken off the 200 picofarad capacitors inside. Are they 100 picofarads? Yes, they are. Okay. This one has got this has got a 100 and a 180 actually. I'm not going to 180 cats, but I will put a 100 and a 68 in parallel for that. I'll also check the inside here, the two things which you turn, and now that them work with the capacity in place, not in place, they wouldn't do. But so I'll change those and look at it and see if that's okay in there. If it's not, what I've done in the past is I've got the two and two things that glued them back together and put them back in again. What these are a ceramic trimmer with a bit of metal on the end inside, and sometimes the metal comes off. Now, it isn't a problem in many cases unless the spring inside is faulty as well. So what I do is I'll take the whole lot apart, redo them and put them together again. We don't have the problem that they have in America with these things, the problem with silver microdeeds, but we do have this problem over here. So this is how we tackle these over here. So what I'll do with this one, I'll put in the capacitors correctly again. I know where they go. I've made pictures, by the way, as well, so I know to put them back in right as well. And from there, we should maybe get something to and tune it up on the IF again as well. Then we might even get something through it. Never know. But this normally I wouldn't bother with a radio of this type, but I want to show how to do it because it's very important that you know this for more important sets. And with a set like this, if I make a mess of it, which I might do, you never know. We know, you know, it doesn't matter. But I think I can get this working. So I will do that, and then when this is finished, I will put it back in and see, and do the other one as well, and see if it then tuned up okay on the IF, which was way off. I mean, way off. It's around at 560 or thereabouts. So put these right and take it from there. Here is part of the circuit, and the part of the circuit in question is the valve, which is there, very new, don't worry about that, and the coil, which is L7 and L8 just here. And across them are two capacitors, C19 and C20, which I've taken out in this case because they were, shall we say, cracked, and therefore not working, which is probably why it wasn't tuned. So basically, what all an IFC is basically is a transformer, and the idea is that that's one frequency through, the one on this case 470 kilohertz. From the oscillator circuit, a number of frequencies come through, but there's only one we want, and that is the IFT on 470 kilohertz. 470 is the only one that gets through. The rest should, of course, be put away, as it were. But in this case, nothing was getting through. It was way off, and only one out of the four adjustments works. Adjustment, by the way, there's two for IFT. I can show you here. You see that's an IFT in question. That's an IFT, and they have usually they have two slugs. One at the top there, and one at the bottom, which is there. Okay. What they do is they vary the value of the coil, and of course the capacitor across it as well. So that's all an IFT is. All this is. Usually it's one jump box you can put it in, but in this case there hasn't, so we're doing it this way, okay? Now how do you tune it for in the radio? Well, you do that by using a tune generator and a scope, and I'll just turn you around so you can see them, and I'll show you what I've done here. That's the scope linked to a signal generator, and the signal generator is putting out the maximum possible signal on 470 kilohertz. The mod is off, by the way. If we put the mod on, very briefly, it goes that because the mod's on top, but it's off for now, okay? And so what I'm going to do is put this, put the IFT across it while I've changed the capacitors and tune it in. But before I do that, I'm going to look inside and make sure that the slugs are okay as well. Before I go any further, I've got the thing out on the bench here, held together by my extra hand here. Not the hand that doesn't work, something which I've made to compensate for that little problem in myself. So at this point, next thing we'll look at is make sure that these coils conduct okay. which we do there, doing that. That's okay. And the other side, of course, like that. And of course, shouldn't be anything between them. There's not okay. So the coils are okay. Good. Now inside of the coils, there are formers, yeah, that come out, yeah, slugs, yeah, and they come out. Okay. These are what you use to set the IF on the radio. Yeah. So this one comes out like that. There you go, right. That's okay. And so that's okay. And the other one, have a quick look inside. That's okay as well. So we'll put that one back in. Okay. Was it easier said than done? But always be careful with these, by the way, because they can snap very easily. So always be careful with these. If you're not sure, don't take any chances. Okay, just don't. Okay, it's something which you know you really must be wary of. Now the capacitors, new ones are in place, otherwise they've been soldered up. So now that is tuned up correctly. And if it has not went out like that, see, that tunes it in off. So that is now tuned at round about, or was tuned round about 470 kilohertz. I'm afraid the connections are a bit dicky, but that is around about 470 kilohertz. So that one is now done. Okay, it's putting out just under 2 volts, as you see on the scope there. That's set on the 1 volt division range, so put it 1.6 volts on the signal generator. I'll tell you what the signal generator about. I can see. So it's all now tuned to that frequency. That's how IF works. You see, that's how IF works. So that one, it might not be perfect, but it still pass something anyway. So now I'll make the inside of here. Hang on. That's the case for it. Of course, the inside of it is conductive. Before it had like paper wrapped around it, which is done in time. So I made the inside of that non-conductive with the insulation tape, and put it together again and check it, make sure it's still okay. If it is, then put it back in the set and look at the other one, which is equally affected. When you're repairing anything like a radio or a TV or a tape recorder or anything, plans can change, and they have with this. One of these has a coil which is not open circuit but not as closed circuit as it should be. It varies depending on the time of day. So obviously something on that coil is not quite right. And the other one doesn't tune up, so again there's something there. So I'll put the other side, look to the junk box, and lo and behold, I have 2 others which come up rather better. So what I'm going to do now is get these into this radio, yeah, one at a time. Yeah, I've marked them, by the way. This one is the is L8. It's linked to V1, the UCH. That's that one, yeah. And this one is the one that goes to V2. So it's so we know which is which. Okay. I don't know how much it matters, but you know I did mark them as to what was what. So I'll put them in as they could be. Okay, it's simple enough. So this one is the first one I'll put in, and with this one, what I'll do is I'll put it in such a way as to be reasonably sure this will work. I hope. You never know with things like this. You never know with things like this. So what I'll do, I'll put this one in and we'll see what happens. It won't speak this yet, but I might get the IF through a bit better. Well, at this stage now, one of them has been wired in, not been put in securely yet, but wired in and put somewhere safe. Now at this stage, valve 2 on this is a UBF80. Now this valve does three things. It does them rather well actually. Basically, well, 4 in a way. First of all, it acts as the first air amplifier, which I'm going to demonstrate by doing that. You see, hear it? That's the first amplifier, and I'll just unplug that. Right. Also, that will not vary with the volume control because the second IFT is not in, and the second IFT volume control goes through it as well. It's quite interesting. There's a circuit just for your information. If you look at valve 2 there, the volume control is R13. Now R13 goes through the other IF cam, if you look. So all goes through that other IF cam. So the other one has to be in. So that's what we're going to do now. And hopefully that might even get some IF through as well. You never know, do you? But you never know. But this valve 2, it also uses the same pentode. It's a pentode, if you look. It's a pentode. It also uses that as an IF amp as well. And the 2 diodes, one is for the audio and one is for the AFC. So ADC. So that valve does in a way 4 things. It is wired right, by the way. So now I'm going to put the second IF can in and we'll see what happens. Well, as you can hear, the set is now working just, except when you have the volume. Now the number of capacitors I took out to get this, to get the cap, the RT in, so put those back in as well. But it is doing something there which it didn't before, so we now get it somewhere. So what I'm going to do now is try and put those things in, those IFTs in a way which is permanent, and because they do apparently work, and then tune the radio as best I can. With a set like this, chances are that every pot has been twiddled. Okay, them I've replaced, okay, but this as well here. See? So chances are that's been twiddled with as well. But what I'll do first of all, I will try and put some IF into it without forcing the thing to switch off. So that goes onto there, like that. That goes off like that. That goes on. And it's not too far off. It's not on, but it's not too far off. So I'll second touch, it is quite a way off. So I think the next thing we need to do here is get the IF tuned up right. With the IF tuned up right, then we can go to the RF side. Remember, PAIR. So I get these in securely, and then I'll get this witness to say it again. You see, I tuned the best I could out of the set, but obviously in the set, of course, with other components around them out of position like that, they will have changed. So now they're in the set. I will try again to tune them up and make it right. There is actually, in many cases, things you can do like this. It won't be as good as it was before, but at least it's doing something now, and I've got to get it as good as I can. There's not so long way, by the way, which is vaguely worrying, but we'll come to that when we come to it. On these sets, all it'll be as a guess is either C3 at the beginning there, or possibly there's a other coil and resistance. So I'll look closely at coil L4 again on the circuit there. See L4, so it might be something on the frequency changer valve. But first of all, let's get the IF right. With the new IFTs in, I now get this. That's 5 live. It's about the right volume, but at the wrong place on the dial. Put the dial in where it is now. You see it's actually at it's actually quite a way down from where it should be. It's about, looking at that, actually, it's about where torch sport should be. It should be here. It's here, and therefore, before I start tuning it up properly, I think the IF is about right now after twiddling with it, so tuning it up. We now have to try and set the RF. Now the RF on this, actually, there are of course two. There's a trimmer and a padder. A trimmer trims it up and down, and a padder takes it but with one end but not the other. Think of one as an up and down, and one as a stretch and a stretcher. Yeah, I think stretch up or narrow it down. That's how it happens. Okay, that's how it happens. So the tuning cap's okay, because of course I can.
And then they is complicated. Hastings Direct Car Insurance is simple.
That's Torch Sport. I use Torch Sport and 5 Live because of course I can't play music on this channel, although I do sometimes. So that's the next thing. This radio is being a little soft, but we're getting there slowly but surely. Is it going to worth it? Probably not. But what you learn from it is what matters, because what you learn from doing a set like this, you will get elsewhere. So now we get valve 1 up and running on medium wave here. It's C13 and C12 is one across here as well, and C12 doesn't appear to have something into setting it properly, so C12 might be an exportive call. Right, well, it is working as good as I can get it. If I just switch on like that. Now the problem here actually, it's had several actually, but the thing that I can't really solve right now with it.
It's on the left hand side, 0-0.
There's 5 Live there. The thing which I can't actually solve with it until I get another Ferguson radio of the same kind in worse condition, that's a laugh, is that first of all, every cap has been replaced apart from one which should be on this. On this set, the bias voltage is set below earth. Earth to the chassis is not earth to the plug, which is why whenever we connected the serial generator to it, it did interesting things like cut the mains off. Did that twice actually. But I've managed to tune it up as best I can with the new IFTs in. The new IFTs were because those have been played about with so much that they weren't IFTing anymore. An IF transformer simply allows to one IF frequency and no others, which they're now doing correctly. It doesn't work on long wave. I've tried. It works on medium wave, but not as well as it should be. And the reason for that is that these coils seem to have lost the Q. Now, over time, bandwidth and Q are linked. Oh, they are linked from day one. But for some reason on this, they seem to have lost the Q. So I can't seem to put what I could because various coils aren't up to it. Now, why that's happened, I don't know, but it is actually now working, so to speak. So what I'm going to do with it now is I'm going to put it together as it is, and that will be it, because until a set comes along with better coils for it, not really a lot you can do. That's TalkSport. That's Virgin. Very quiet. And that's it. So there you are. That's the state we're up to with it. Also, I think Y2 these valves are a bit past their best as well, because on sets like this, on say the EBF 80, yeah, that actually amplifies it twice. Once as RF at IF, and once again at AF. And the only capacitor which hadn't been changed is there's one which feeds the AF to the 8-foot pentode, which didn't survive. I've got one in, but I'm not putting a good one, a non-good one in this, because I'm not. It's not worth it. But as it stands, it works as a radio. Not terribly well, but it does work after all this time and patience. Doesn't make any horrible noise anymore. So I'm going to put it together, and with a set like this in particular, it's going to be a case of get it partly together, try it, get it partly together, try it. Also, this set really should have a better medley on it, but I don't think I'm going to in this case, because I don't think, in all honesty, it is worth it. I'm sorry, but there you go. Some sets are, some sets aren't. And this, I've learned a lot from it, by the way, don't get me wrong. What I've taught you some interesting things from it as well. But sometimes you have to accept things for what they are, and this, I think, is one of those sets.
But the roofing cars.
Well, here it is working as far as I'm willing to go with it. I only get 2 or 3 stations because, as I said, the Q is gone on the coils. Why, I don't know, but it has.
The part is mapped out.
Also, there's a problem with the antenna as well. But I'm going to leave that because I don't know what's causing it. I really don't. There's nothing to cause it, what it is. I've shielded things, I've capacitated things, I've capacitors on things, I've done all sorts, but it doesn't do it. But with this set apart,
And Anthony right now. So if that was a chance,
it does actually work. Sound good on the chasings it does get. So anyway, that's it. That's the Ferguson 351U, which cost me £5 from Gorborn, and I've been £5 worth of fun with it. It's had a lot done to it by the previous person, and a lot of time spent with me putting it right. Parts missing, parts of shouldn't change that weren't, all sorts. So it does work. What I might well do actually with the antenna side of it in the future is probably change it back to an older version and put it on the 8-side antenna when I come to use it. But it does work. So there we are. It's a working radio again, just about. Some radios you just can't go any further with them. The reason for that is that somebody trying to restore this and not doing a terribly good job.
Which, by the way, the body language I didn't like at all. Going in, looking at the way in and stuff like that. Fury's
Some, but why that
I
is,
think you have to.
I really don't know.
Well, you've got to have fast feet, you've got to close the distance, and you've got to let them fly. And I think
Wait, that's talk sport.
if he can beat him, then we've got to fight.
That's Radio 5 Live. There's not a lot of scope for long wave either because, well, the cause it appears to be open circuit again. So this one, I'm afraid, it's not a complete wow, but I'm not taking it any further because I've got a lot to do. So the people that wanted it repaired says it is a challenge to make it work again. I did make it work again. So I think the challenge has been accepted and won. So until next time, this is Steve Pendlebury at the Long Stay Workshop saying thanks for very much for coming and supporting me through this set, and I'll be back soon with something else equally bad. I hope not. See you soon and bye bye. When it comes on again, you should do it very quickly. Valves, you see, to take time. But there you are. So until next time, goodbye and take care.
Boxing royalty. Amanda Serrano has hustled for years through the